All right, well, we're going to get started today. Good morning, everybody. Hope you're doing well. Thank you for joining Data Science, Machine Learning, and AI Meetup today. Uh, Due to the current situation, as you all are aware, of course, we wanted to continue our learning process and our meetup gatherings virtually. We hope to come back soon to our local chapters in Birmingham, Alabama, Charlotte, and Jacksonville face to face. But until then, until we're able to all safe, be able to do that and see you face to face, we will continue to do this virtual meetups. Today we have a great speaker, Rick Hurst. I will do an intro and bio of his background and experience with today's topic and presentation. Before we do that, I'd like to, for those of you that are new to the meetups, that Syntelli Solutions um, supports and manages and collaborates throughout the year. We've been doing this for several years in Charlotte, our home office, and currently we are also hosting these in Jacksonville as well as in Birmingham, Alabama. So to that, I wanted to share that with you. You are familiar probably that the meetups are happening in one of the cities, but we have 3 chapters going on. You can share that with your colleagues or with other friends and peers that may want to join these meetups. You can go to meetup.com and look for data science, machine learning, and AI chapters in those 3 cities and join one of those or join multiple if you want to do that. Our continued learning experience in these meetups has grown over the last few years and more recently in the last couple of years. And we have well over 1,400 members now in Charlotte, over 400 in Birmingham, and I think it's over 500 now in Jacksonville. You have supported this, all of you that have attended, met you face to face, have supported this endeavor, and we really appreciate your collaboration and learning experience as we all learn more about data science and the topics and the leaders that are in this area. So we look forward to continuing that in this new virtual environment, as I mentioned earlier, until we can do otherwise and see you face to face. With that, I'm gonna introduce Rick. I'm gonna give you a little bit of his background and experience. Rick Hertz is the director of artificial intelligence, Camgian Microsystems, overseeing multiple projects involving AI, machine learning, and computer vision. He received his Bachelor of Science from Florida State University in software engineering and Master of Science in software engineer at University of West Florida, Pensacola, Florida. Prior to his current role at Camgian, Mr. Hurst led both product and team in the development delivery of autonomous solutions for underwater vehicles, inclusive of AI designed to augment the cognitive capacities of human agents, predictive and adaptive mission planning, in-situ replanning, computer vision, and fire control. He manages all aspects of the product lifecycle, from project scope work through provision of deliverables to that of roadmap and identification of future capabilities. The specific technical interests include several areas beneath the AI umbrella, inclusive of predictive analytics, adaptive learning, cognitive computing, and computer vision. Rick has established multiple partnerships with synergistic organizations such as IHMC in various universities in an effort to cross-pollinate and collaborate on various projects of mutual interest. Rick plays the role of innovator, has established 2 companies that delve into the AI arena, in particular healthy hives, in an effort to reduce the rapid decline in honeybee populations by analyzing various metrics. So you can, based on his background, his experience, you can see that Rick has a ton of knowledge in machine learning and AI. We'll look forward to his presentation today. Rick, thank you very much for supporting um, this community, the Meetup community from Intelligent Solutions, and really appreciate you taking the time today to present your insights and your thoughts on today's presentation. With that, I'm going to turn it over to Rick to start the presentation. Thank you, Rick.
All right, sounds good. Let me share the screen and make sure. Looks like you're still sharing.
Stop sharing. Try now.
Okay. All right, we should be able to see the main screen.
Yes, we're good. Thank
Sounds
you.
good. So just to give an idea of what we do here at Camgian, part of our portfolio involves the Wall Street sector, financial sector, what we call fintech, to where we do some data analytics, predictive analytics, much of that being based on various imagery that we collect in the field. Can't go into the details of how we utilize that imagery, but we do work with various hedge fund managers, people of that nature, to give them a little heads up, a little bit of insight into where particular markets might be going. That has worked very well. Our accuracy is very high. The other side of the fence is we work with the DoD sector, in that we use computer vision techniques in such a way that we discern between an adversary and somebody that may be not very much of a threat. So for instance, if we have cameras, if we have troops that are marching along and we might plant a few cameras behind them, we're able to alert them in advance, A, if there's anything happening behind them, so that they don't get ambushed, and B, is this particular person that's in this particular area, are they holding a weapon, or are they holding a stick and just herding sheep? So computer vision is our main course, and AI is the umbrella for which from which we live under. So on that note, we will continue on. So the topic that we're going to look at today is complexities of computer vision within uncertain operational physical environments. And the title sounds complex, but really what the idea here is to convey is a little bit of AI. So what I've discovered as I've journeyed to different locations with quite the variety of people is that not everybody understands AI. From the highest levels of the CIO, CTO, downward to the boots on the ground that are looking under the hood. AI is usually combined with ML. I don't really think that's the most appropriate way to combine those two terms. They are different. In the old days, AI would be more of the Terminator kind of robotic, kind of taking over the world, HAL kind of scenarios. But cognitive capabilities have been somewhat elusive. So I think over time, these acronyms have kind of just been joined. So there's a lot of buzzwords and a lot of misunderstandings as to what artificial intelligence is and to what it is not. And even through some of these presentations, like for instance, going to naval research labs or various areas to where these communities of interest might be joining, what I've discovered is that we're all somewhat in the same boat. Going to these areas to where you think you're going to meet it up with the experts, you find out that those experts think that you're bringing the expertise. So it's quite an interesting dynamic, and that it's a forefront of technology that very few have a very deep understanding of, and the majority of people are still trying to feel their way around, yet don't want to expose their Achilles heel in such a way that it might expose their vulnerabilities to lack of the knowledge. So we will move on to this slide. Is kind of verbose. My slides don't typically have a lot of verbiage in it. I'll leave it here. If somebody wants to look at it later, I won't really read through it. It was just some kind of a direction to where at least the DoD, the government, was kind of leading towards. AI, computer vision, all of these subtopics underneath the AI umbrella are becoming quite in demand, especially when we look at the adversarial landscape and just the private sector and how quick they're moving in general. So to give a little history onto how I got to where I am, my initial career track was in the microbiology domain. Took a step back from that, went into software, and got picked up by a company called Iserona. They were a small startup that got acquired by this guy called Dr. Patrick Soon-Shiong. So what Soon-Shiong did is he aggregated about 20 companies together. And his goal was to, throughout these different company techniques, these different modalities, consuming all of this various medical data, his goal was to kind of get into the predictive analytics arena as it relates to medicine, using the what we call as a term IoT, Internet of Things. So how can we aggregate a bunch of disparate pieces of information in such a way that we can kind of predict what's going to happen, in such a way that we can alert you 72 hours in advance that you might need to go see a specialist or an ER physician because there's an 85% likelihood that you might have a cardiac event, things of that nature. So one of the products that I was over, a product line, was medication adherence with the Glow Cap and Glow Pack, which did just that. It took track of when you took your medications, and the efficacy of those medications can be tracked by how well you're doing. But the main point here is that when we joined Patrick Soon-Shiong in his effort to kind of as boil the ocean, as he would say, in the medical arena and this artificial intelligence, predictive analytics arena, one thing I did learn is that you can't buy artificial intelligence. So regardless of how much money you have, this isn't something that you can buy. The government can't buy it. The rich people can't buy it. Big corporations can't buy it. They can move towards it, but it's not a given just because you're a large organization that you're going to be successful with it. Another piece of the puzzle that we did, and kind of given an overview of what this aggregation means. So when you look on the left side of the screen, you'll see these different components, these data points. And when you look into a chart, it looks pretty complex. So the idea is, how do you take all of these disparate data points and put them into kind of a viewable scenario to where the average person, the layman, the person, or even the nurse, or even the doctor that might look at this can say, okay, you're doing well here, not well there. And that was the concept of My Life Index. So this particular product isn't around anymore, but my goal here is just to give an idea of what data analytics means, what predictive analytics means, and how this all ties in to predict an outcome forthcoming to a particular individual or scenario. Another product that we developed kind of as a hobby, there was a scenario a few years back where bees were dropping in population quite a bit. It's called colony collapse disorder. And this is the same scenario. How can we take data points out of a hive and try to understand when these bees are about to leave the hive? So the colony collapse is a scenario to where bees will just leave. There's no real rhyme or reason to why they're leaving, and that's what the big effort and these research studies are striving to achieve. So we developed a sensor that collected temperature, humidity, various data metrics coming out of the hive. We would push those into a cloud-based system and do some analytics on it and color-based those analytics to where we think the state of the hive's health, hence the name Healthy Hive, is in. Green being good, yellow you need to check on it, and red is quite a bit of danger or just collapsed altogether. So that's another way that you can take data, put it all together, analyze it, and kind of predict a scenario that's yet to happen. And with the Navy, from where I just recently came from, my role was to help manage a team that designed an autonomous underwater vehicle in such a way that we take the human out of the loop and out of danger. Drive this vehicle in adversarial waters and kind of stake out the situation or run various scenarios. These topics I can't get into because of the classification nature of it. And this particular submarine is a commercial side of the fence. It's not really the DoD one, but it's the one that we tested throughout. So big component of artificial intelligence isn't necessarily how do we make this thing think like a human, but how do we try to make it think like a human? And that's what autonomous vehicles are striving to do, is how can they make decisions with humans out of the loop which we've not completely achieved yet. But how can you put them out there when they're not able to communicate and make decisions on their own and make the right decisions to where they don't create collateral damage unnecessarily? And we can certainly ask questions to any of this after the slides are over. Normally, when I do presentations like this, it's very interactive, but certainly jot down whatever questions you might have and we can circle back to them. So artificial intelligence in general, what is it? So if you go along this, this diagram here, you'll see each one is pointed to is green. So we've achieved a little bit of everything except what I would call cognitive behaviors. A lot of people think that we have, but I've yet to see that in person. Every time that I run into a scenario or talk with a group of people that feel that they've incorporated some kind of human thinking or cognitive behavior into a system, when they go back, in reality, all the system has done is really what it's been programmed to do. So that is the pinnacle of what artificial intelligence is thought to be and what we're all striving to achieve, but we're far from it. We can look at patterns of behavior. We can identify scenarios that repeat themselves or imagery that looks like this or that, and kind of over time and training these systems, we can teach it to do various things, but in the end, they're just doing what we really told it to do. They have not extended beyond thinking for themselves, learning from themselves, making decisions for themselves, and then kind of adapting on their own in ways that we've not yet seen. Can they tell us information that we've not yet thought about? Sure, their computational power is extreme, it's quick, far better than anything a human mind can do, but their ability to think and learn from past experiences on their own and adapt and make better of themselves going forward, that's not yet been achieved, or at least nothing in my travels have I seen it to be achieved. Everything is code-based and programmatic in nature. So what is artificial intelligence? Again, we're going to keep this at a higher level. And on side conversations, we can certainly go into a deep dive if anybody would like to do that. But it kind of separates into strong AI and weak AI. Strong AI is really where the AI system can think and have a mind of its own, understand itself well enough to self-improve. Pretty much what we discussed on the previous slide. In contrast, the weak AI system can only think like and act like it has a mind of its own. And going back, it's really what's artificial intelligence and what's programmatic intelligence. What we have today is really programmatic intelligence. It's systems that are doing what they've been programmed to do. Every once in a while, they will do something that surprises us, and we think that maybe we've broke the mold, that we've moved forward, that we've achieved something yet to be achieved. But again, every time we go back and we look at the code, the underlying programmatics that are written, the system's really only done what we've instructed it to do. And that's pretty much what this slide describes as well. So artificial intelligence and programmatic intelligence, they're just not the same. They're not equal. So that's kind of given a little bit of insight into what artificial intelligence is and what it isn't. It has a lot of subcomponents beneath its umbrella, but I think the buzzword itself is many times misused. It's thought of to be more than what it is, but it's really a generic term that encompasses any way that we're trying to make a machine or a system think and behave as a human would, but without the human in the loop. And much of what we do is supervise. So we manage and we get feedback from these intelligent systems. And then as the human gets that feedback, they make decisions for the next steps going forward. Whereas unsupervised would be no human in the loop. It would have the capabilities of making decisions in stride on its own and going forward without us. All right, so going underneath the artificial intelligence umbrella, we get into the topic of machine learning. And this basically what I'm doing is I'm taking a few steps towards talking about the computer vision component of artificial intelligence, which what we do. So in machine learning, basically this requires data, a lot of data. We're taking a system that essentially has the capability to learn, similar to what a 5-year-old might do, and we're feeding it patterns of information. We're feeding it data points. We're feeding it something that's similar in nature, and a lot of data points that are similar in nature, and we're hoping that this system will learn, see different types of patterns, and learn how to kind of predict and make decisions on its own based on the history that we've fed it over time. This becomes somewhat of a problem in that data is not always available, and these systems do not work well without a lot of data to learn from. So as we get into the computer vision arena, it's essentially the machine learning concept. So what we're doing is we're labeling these images. So what computer vision in short is, if you look at the video to the top left and the images to the top right, it's taken particular pieces of an image and it's identifying those items within that image. So to get to this point, you have to, get a lot of data, different perspectives of that data, different angles, different environments. Like for instance, the car, you have to take a lot of pictures of this particular car, and then you have to manually, so we need people to train these systems by manually drawing boxes or kind of outlining each individual image and then feeding this into the system. So for example, just to identify that car, maybe there's 2,000 images that a human, and typically students are fantastic for this when they're starting to get into computer vision, is they go through each image and they outline the target of interest within that image. They feed all of these into a system that starts to learn the particular patterns of what's been outlined. And this is called labeling of data. Now, there's some issues with that. Sometimes it's not very easy to collect the data. For instance, with Facebook and facial recognition, what makes it very easy and keeps them on the cutting edge of computer vision is that we're kind of giving them the data. Every time we upload a picture, every time we store data, we give them our images to play with, which under normal circumstances and the environment that we live in today, there's some privacy issues that would normally keep them from obtaining the data, but kind of as a side effort that they do, not only do they provide us a way to interact with our peers, but they're taking that same data and they're learning from it. It's not a bad thing, it's a good thing, and it puts them at the forefront of the computer vision technology. So when we start advancing this over to, say, medicine, I believe typically these sessions are over at UAB, which is why I incorporated this. It's the same concept. So one nice thing about computer vision is that it really doesn't matter which domain that you're in or from. It's all essentially the same. So when we look at an X-ray or a microscopy or some kind of PET scan or some kind of image, they're usually 2D and many times 3D, but you can take a slice of that data and there's certain patterns that you can look for. So in the case of this chest X-ray, is you can identify some spreading. So the item on the right, and I can't give you the details of why it's 85% positive, but they've taken particular components and data points of this image, and they've discerned over many trials and error of pushing data into these learning systems that the likelihood of this person having pneumonia is at 85%. So again, this, especially in the medical arena, it's very hard to train these systems because of PHI. Patient health information is very restrictive, as opposed to, say, other countries like China, where this information is more readily available because they don't have the same laws and restrictions that we have. So if we get enough of this data, which has been analyzed and identified by, let's say in this case, a radiologist or a physician, and labeled, then we can feed those images into a system that's going to learn and more rapidly be able to identify and detect, in this case, pneumonia or let's say cancer, much quicker than a radiologist might be able to do, just because of the limitations of the human mind and the ability to go through these images. But the only problem in a case like this is a matter of trust. Do we trust the system? And that is one of the pieces that keeps us from moving forward with full autonomous systems is the ability to trust the machine and its decisions that it makes. So these are kind of crutches to the medical arena in that they can help the physician identify or detect things that they might otherwise not be able to detect, but ultimately still has to have a human into loop so that it can make a decision on what's really going on with this patient. And I actually wish I could ask questions during this session, but anyway, make note of that and we'll certainly come back to it. So how does this labeling technique work? So just if you look at something simple, such as the image of the cat, the dog, the little duck in the middle. And these are the labeling techniques that I was speaking to earlier, to where you can get a student that takes an image and they kind of block out the background in such a way that they're boxing around the image, or they're using segmentation techniques to kind of get more of a finer detail on what that image is. And that's what I mean by labeling, is that you're isolating with a human what is a cat, what is a dog, what is a duck. And then you're feeding these into a system that over time and over thousands and thousands of images that have already been labeled, it starts to learning characteristics and features. Like for instance, maybe the eyes are so far apart that represents a human or a duck or a cat, or the ears are up, or there's some kind of coloration that you can look at and say, okay, this isn't character A or character B, but you can isolate it over time to really identify what type of animal it is. So that's the start of computer vision and training the system. Now, where it really gets complicated, and the original intent of this discussion, I was going to speak at Oceans in Seattle last year, and we were talking about subsea complexities. So when you train a system, ideally, you have these pictures, they're in perfect shape, there's nothing wrong with them. So that over time, when you train a system, it's really not that difficult. It's kind of easy, really, when you try to look at shapes and whatnot. Where the problem comes in, like for instance, if you're looking for an object of that's underwater. So in this case, subsea ATR, automatic target recognition. When you're looking at something underwater and it's got a particular shape, you may have a cloudy environment. You may have a bloom of some kind of biological. You may have sand going over the object. So what originally might be a circle that you're looking for, let's just assume our target of interest is a circle, might now be maybe a triangle because the sand has partly covered the object, or maybe the water is cloudy. So how do you incorporate those complexities into a system so that it understands that it's one object over the other? And that's not an easy thing to do. And in fact, that causes a lot of false negatives and false positives. And those are the things that make computer vision so difficult. Is it's not just the image that you're looking at, but it's the environment as well. So in the case of underwater, you have the turbidity of the water, you have sand, you have currents, you have those things of that nature. And in the case of being on land, so if you're looking at a particular car, now start to think what that car looks like when you have snow, rain, fog, nighttime, or even a sun setting that creates a glare along the edge of a window that causes that car not to really look like that car. To a human, you can readily identify that it's a car, but to a machine that's going pixel by pixel trying to find out where this car picture starts and where it ends, the dynamics have completely changed. So when you add the environment to the picture and how the environment changes over time, it really creates a burden on the ability to identify this imagery accurately. So going back to the x-rays here, it's the same thing. So if you look at this image and you just watch the spread of pneumonia over this person's lungs, it becomes somewhat trivial to identify, okay, we've got this cloudiness in this particular area, so it's obviously pneumonia. But now again, when you talk about environment, the body's an environment, right? So let's start incorporating weight. So instead of a 185-pound person, this is a 300-pound person that has a lot of congestive heart failure. So now we're adding fluids into the mix that make it more difficult to discern between, is this pneumonia that's spreading, or is this a fluid? Or you add some other morbidities, say that there's a tumor in the mix or something of that nature. So now we're adding complexities, random complexities, that make this simplistic image much more complex, and we have to count for that. So one way you can do that is you can, incorporate into the system these different data points that it takes into account for, okay, this person has cancer, but simply looking at the image as what computer vision techniques typically do, ingesting these images and learning over time, you have to start incorporating these complexities. Otherwise, your accuracy is just going to go off the charts. You're going to throw false positives and false negatives. So that's with still pictures. So then we start talking about, well, what about video? Video is in essence just a series of still pictures, right? So one of the techniques that can be used in video is if you have a camera facing a particular location, what's the one thing that stays the same? The background. So we can take over a series of images and we can identify those pixels that just don't change and remove them. So that's what's happening here. Is on the left you have a picture of a horse. On the right you just have kind of the color image and the background is black. So basically we've taken the pixels that just don't change over time. We've taken them out of the scenario and we've simplified the image so that the outline more resembles what the target of interest is that we're looking for. So that's fantastic, and that works pretty well when you have not a multitude of images that you're looking for, as in the bottom, to where you have multiple objects that you're trying to discern and detect. But it still creates a much simpler way of trying to identify objects in the picture that are moving. Now, if we do the same scenario and we have a camera that moves back and forth, or we have, in this case of these images here, the environment changes dynamically over time, every single one of these images is separate. So that's not going to work, and that you can take the background and just remove it. You're going to have to analyze these each separately. And the problem with computer vision is it's very computationally intensive. So the bigger the image, the more items that you're looking for, the more items that you're trying to segregate. It makes it very difficult to do and time consuming. And that's one of the things that everyone's trying to get to. So you might see, I think it was during the Super Bowl, or there's some commercials to where Microsoft is touting that they fly along the side of a mountain, and they can identify mountain goats on the mountain. Now through the commercial, and of course marketing works this way, is that it looks pretty accurate, it looks pretty cool. But I'm pretty confident, and I don't know the accuracy of what Microsoft is doing with these computer vision techniques, but I'm pretty confident it probably took them 100 tries to get that one accurate picture and label, and it's not as great as what the commercial might convey. This is not an easy thing to do. There's a lot of things that factor in that can throw the computer vision's accuracy off. So when you see or hear or companies tout how great their accuracy is, I would certainly question it. I think we're all in the same boat, and that we're all, so one thing that's really interesting about computer vision is we're kind of all in the same playing field, except for maybe some of the greats. You have the Googles, the Facebooks, but for the most part, for 95% of the people and organizations that are in this domain, we all use the same frameworks that they put out, like TensorFlow. So the playing field is about the same for everybody. It's how much data you have and how you can feed that into the system, and various ways that you're labeling and techniques that you're using within these frameworks that really separate one organization from the other. So we're all kind of in the same boat. So when I see a company that touts that they're far greater and far exceeding everything that everybody else is doing, I certainly question that. All right, so how do the Facebooks and people of that nature do it, and how are they successful? So there's kind of these tricks of the trade. So think, for instance, when you do the reCAPTCHA. For those that don't know what reCAPTCHA is, it's kind of a security component in such a way that you've got to identify certain objects within a picture and verify, like for instance, a street sign. So there might be nine images there. You have to pick out the street sign in each one of those. So maybe 3 of those sectors or squares or street signs. So think of it this way. Not only is that a security feature showing that a human's making decisions on these street signs, and they obfuscate things in certain ways, if you might notice, so that you can't really train a system to pick out everything. But, and I don't know if reCAPTCHA is doing this, but I'd be surprised if they're not. But basically, when you're making those decisions on reCAPTCHA, you're kind of training their systems for them. So they're showing you a bunch of images. They may have a system in the background deciding on what's a stop sign, what's not, and you're kind of confirming whether or not they are or not. So it's kind of an interesting dynamic of how you can use the community as a whole to help train your system and increase its level of accuracy on identifying imagery that's out in the public. Same thing with Facebook. Facebook, and even say when they offer you technology such as Google Drive or Photos, it might make you wonder, how can I upload all of these videos and these images at a low cost or even free? What does Facebook get out of this? And basically, you're giving them data that they really don't have access to on their own. You're providing them data sets in large volumes that they can sit there and train their systems on, that they can turn around and use those systems for other things to generate revenue. So it's not really as free as you might think it is, but it's very beneficial to the company to get as much data. And if it's free, you tend to upload and do a lot of things that you normally otherwise wouldn't do. So let's switch a little bit over to China. And the reason I bring China into the mix is that there's a lot of hype with them on making claims to be the AI leader by 2024, 25, 2030. And this kind of coincides to what makes them so different. Or even Russia or some other country that may, and I don't want to call them adversaries, that we might be in a little bit of competition with. So rolling back to machine learning, computer vision, and these types of techniques, what's the key feature to all of this? And that's data. The more data you have, the more data points you have, the more images that you have, the more successful you are going to be at training the systems, more accurate your outcome's going to be. These countries do not have the regulations, the privacy that the US has, which gives them an unbelievable advantage to advancing their technologies. Absolutely unbelievable advantage. So when you do see these claims that these countries are going to be leading in the efforts, that's fairly accurate. They have the things that we don't have access to. That's a concern. So that's something that we will have to kind of keep an eye on and figure out other ways or techniques that we can advance our technologies without suppressing our freedoms. And one way to do this is by generating things synthetically. So one of the things that we have the capability of doing is replicating environments synthetically through using 3D models and things of that nature. And that's how we can, like for instance, you can take an image and overlay it with weather patterns. We can synthetically create thousands upon thousands of images that are real or not real, but we can augment those images with various scenarios to reduce our costs and give us the capabilities of procuring vast amounts of data that we otherwise wouldn't be able to do. So things of that nature are advantageous to us, but we're going to have to figure out a lot of different ways to stay competitive in this market, at least from a global scale. All right, going to the next slide. And this is kind of one of the things that I harp on quite a bit. This AI sector is it's a very specialized sector. It's many times very misunderstood. But when you look at those people coming out of the colleges or different industries, it's kind of tough to find in those that would make good AI machine learning candidates. And I say this because I teach computer science at Florida State. I've been doing so, I don't know, 12, 13 years. And one thing I've noticed over time is that just because you're a software developer does not mean that you can develop in an AI world. And one thing that I have found over time is that, and I do this quite frequently when I interview, is I will ask the candidate, do they play an instrument or are they involved in the arts? And there's a particular reason for why I do this. And I actually had a student one time come to me later and she asked, why did you ask if I played an instrument? And my response was, looking at her resume, I could easily tell that she would be a great candidate. But knowing that she also played an instrument told me that her mindset was a bit creative and that she would be not only a great candidate, but a super candidate. So when you're working with artificial intelligence, any of these subdomains to the topic, the ability to think outside of the box becomes critical. So as a software engineer, you're trained to do things in a certain way programmatically, and that's not necessarily the case with AI. So having that artistic capability will very much so help you in this arena. It just takes you just one step above the others and being able to crack the egg of a situation that you otherwise can't crack. Like for instance, with computer vision, this is nothing really new. When we were compressing files years ago, let's say an image where it would just parse through the pixels and find a series of images and kind of collectively combine them to make that image a little bit smaller that you can expand on later. This stuff was being done in the 80s and 90s. So taking an image and manipulating and doing things with it isn't nothing new. We're just trying to do new things in new ways with it. We're trying to identify what's in the image, where it's moving, what its intent is, things of that nature. Now, the other side of the puzzle is historically, we would think of the DoD as kind of leading the efforts on many of these technological breakthroughs. But with the private sector and the low cost of the components that are out there, that's no longer the case. And the DoD is kind of struggling every time they kind of procure that talent. They're kind of struggling to keep it because they get poached. In my case, I was poached. The pay ranges for this domain can be very high, especially if you're willing to go to the Northeast and out West. So I certainly encourage those who are interested in artificial intelligence to go for it. But no, it's a little different than just software development. It does take some creativity and some thought to be really good at it. And on that note, this is the next to the last slide. Just going over a few images here. So when I talk about that creativity, the young lady in the bottom right is Cassie Cohen. She's probably the one who really solidified my desire to find artistic people. So she was a student and she was very creative in her assignments, and her and I have stayed close, and I followed her throughout her career. She was picked up by Google, went to New Zealand, did an internship. She was one of the architects to Microsoft's Bing, and now she works with Facebook. So if you have that creativity and you combine that with software, it can take you a lot of places. The other pieces of this component, the guy in the bottom middle, that's Steve Millway. He was your creator of the USB 2.0 chipset. The little fly, the fly contraption, that's somebody that I know they developed this human flying machine. It's got some autonomy in it, it can fly around. So there's some really cool things that can be developed under the AI umbrella. And really the sky's just the limit. So on that note, there's our team. Hopefully what I said made sense. Without the interaction, it does make it a little bit tough. And I think we can stop there and take any questions.
Great, thank you, Rick. Appreciate it. Love the flow of the presentation and the use cases and insights. We have a couple of questions. Let's see. One is on the Q&A. Others can go ahead and submit other questions if they have any at the moment. So Chang Lee was asking, in the subsea
ATR slide, the images seem to be labeled by domain experts, as I wouldn't know what to look for. Is that your team's data set? What was your process for getting and refining those labels?
So I believe this is the slide that that person's speaking of. And
Yeah.
the process of getting in there and assigning those labels, I think is the question.
Yes.
So many times these environments are staged. So let's just say, for instance, that we're doing this for a petroleum company, and we're just looking for widget A, B, and C, and we'll just call them shapes: a triangle, square, and a circle. So the best way to start identifying this is we go out there and purposely place these in particular environments. And the reason I'm using them is because the particulars of what I was involved in, I can't speak to. So we're going to stay with the petroleum industry. So we'll go out to, let's just say, the Gulf of Mexico. We're going to place these widgets on the ground, and we're going to run a underwater vehicle over them, and we're going to take imagery. We're going to take a video of these things in the sand. Then we're going to take an expert that knows what these images are supposed to be, and that expert's going to draw the lines as you see around them. Then those images that have been labeled, identified, lines around them, whatever you might want to call it, and essentially we're labeling the data. These images in vast amounts are being fed into the system so it can discern between what a square, a circle, a triangle is. But in the beginning, it's a manual task. These environments have to be created if they don't already exist, which makes it very difficult because when you put an underwater vehicle in motion, it gets very costly. There's a risk of losing the vehicle. These vehicles aren't cheap. The cost of maintaining them is expensive. But it's a manual, very expensive, lengthy setup, and it's done by humans.
Okay, great. Next one comes from Tora Fan. To what extent do you employ GAN or GANs in your computer vision work, and what use cases are you applying
GAA, what is that?
GAN, GAN. I don't know what it is.
Let me take that down and
this person Tora mentioned is generative adversarial networks.
I'm going to say that we don't. I think I've heard of the acronym, but I can certainly look at that and see if I can formulate at least some kind of response, but I couldn't give you one off the cuff.
Okay. Thank you, Tora, for your question. Rick will investigate and get back. Regarding the reCAPTCHA data set, can you explain how the algorithm works to detect the stop sign from the image? I had done the project to break the text based on CAPTCHA, which was quite hard, but regarding detecting object from image and training the model is quite challenging.
Okay, so the techniques that are used in identifying these objects are the same, right? So let's just say that we take 1,000 images, some that have stop signs, some that don't. There's a human in the loop somewhere that's either creating boxes or segmenting these objects to train the system. And as you can notice in a stop sign, you can't always say that it's an octagon because you might hit it at an angle that the octagon really looks like an oval with just a couple points. So how these systems are trained is the same way. Just about every piece of the puzzle with computer vision uses the same methodology. I mean, there's some variants, but for the most part, you're taking a bunch of different images. You are bringing a human into the loop, identifying what the image is, labeling that image, and feeding it into a learning system.
Okay, very good. We have several questions here. I'm just gonna pick a couple until we're top of the hour.
Sure.
With your assessment that AI is very far away from cognition, how does that gel with the dangers of AI by some other notable public figures?
Some other notable public figures.
AI
is probably going to be like Elon Musk and Zuckerberg and their arguments between each other on what it is. So when AI is essentially, so let's take, for instance, just artificial intelligence in of itself and the military. So One thing we don't have is trust. So when we advance AI, everybody wants the advancements, but nobody really wants the accountability or responsibility for those advancements. So trust becomes an issue. Now, on the flip side of things, and trust is an issue because if you develop something and somebody dies in the process because the artificial intelligence makes a bad decision, then it's a bigger deal. Now, the flip side of things is that you have other countries that really aren't as risk averse as we are. So they're advancing as quickly as they possibly can. And like just say for a drone, for instance, we have drones. And when I say drones, I mean like an F4, something that an actual plane that is used we've incorporated autonomy into F4s for F-22s to train and shoot those things down. Other countries, when they incorporate this autonomy, they're trying to take the human out of the loop, the supervision out of the loop, so that their planes can turn around and outfight our fighters. They're not as risk averse. And at some point, there's going to be an inflection to where their autonomy is going to be better than our humans, and we're going to have to advance our systems. But when we go back to incorporating cognitive behaviors, how do these systems make a decision in real time, in stride, on, make a left turn, make a right turn? Is this target likely? What's the likelihood that we're going to intercept this target if we take a shot? And what's the likelihood that we're going to miss and kind of open up our identity and location to where we're at, and they're going to turn around and get us? Those are all programmatic. There's really no system out there that has not been trained in such a way by a human that, no system that I'm aware of. I'm not saying they don't exist. There's all kinds of top secret things, but from my channels, my networks, and people that I've spoken with, nothing exists out there that can think and act autonomously in such a way that you would think that there's a human there. Now, there's different methods to where you can, I forget if it was ADA or I forgot which one it was. There's scenarios where you can run through, and once the human can't detect between another human and a machine, they kind of say that AI is there. But I don't see the scenario to where artificial intelligence is going to take over the world. Everything is pretty much controlled by the human in the loop. I wouldn't say that it's impossible. I would say it's improbable, at least in the near term. But I would say autonomous features that are capable of making decisions without a human in the loop, but based on human programmatics that we've incorporated into the autonomy, that can advance. And that can be an issue, especially in warfare. If somebody figures out the right recipe to make a weapon fully autonomous, to where it can make decisions on its own with a low probability of collateral damage and high probability of accuracy, that's a problem. But it's really not cognitive. It's really just programmatics.
Cool. Thank you, John, for that question. We jump to Ron's questions. I have a question about how practical it is to share the training across projects. So can a new project be built based on prior training and complaints on another project, or does each project have to start again on its own?
So they have, the answer is yes and no. They have generic label data sets that are out there that you're free to use in training your system. Now, for the average, whatever you might do, these data sets might be useful and practical for whatever the mission or whatever you're trying to accomplish, whatever you're trying to train your system to recognize. But when you start getting into more specialized fields, like in the case of maybe detecting an adversary between a sheep herder, those data sets are hard to reuse. And they're very specific if you want to maintain a high level of accuracy and detection. So it's yes and no. It really depends on how specific your mission is of what you're trying to accomplish.
Great. Okay, well, I think this is a great question to wrap it up today because we're getting close to the hour. But can you share some insights from your startup experience in the AI and ML space in regards to selling AI outcomes is a lot different than harder than software, of course, and building and retaining a talented team. You share some of those insights on those two areas.
So in the case of what I've done historically in creating a business is it all really started when our medical device company started doing an IPO. Things got a little shaky and you have these turf wars between companies. So a group of friends got together, and how we built it out was based on what they call sweat equity. So anytime you build a new company, especially a tech company, you have this piece of the puzzle. It's called the Valley of Death, to where you run out of funds, you can't pay somebody, and basically whatever you've developed over time just goes in the garbage for the most part. So for me, I think the best way to do a startup is with sweat equity. You're not really tied to funding because in the beginning you will be have issues with bringing in that revenue before you get that final product out. And again, when you start going through a hiring process, especially in the AI arena, if you're going to get good talent, you're going to have to really search them out and basically poach and pay top dollars for these guys. So if somebody's trying to do a small startup, I would say do it with your friends and do it with some sweat equity, where you create an operating agreement such that each one of the people that are in your group has a vested interest in the success of that group, and are willing to donate their time without the receipt of pay, knowing that the outcome is going to be the pay. And an operating agreement such that if they jump ship early, that they lose their equity. So that's my philosophy on it. And you'll talk to 10, 20 different people. They're all going to have different ideas on how to start up a tech company, an AI company. But I've done that. It's always a struggle creating a startup, especially when you're either you're always going to angel investors or venture capitalists to get money to keep funding your project, or you have a day job, and this is something you do at nights on weekends, which is pretty much my model. So that's a tough one, but my model is get those that you know that are close around you and just give it a go. And the worst case scenario is you've lost some time.
Great thoughts there and insights on getting going on a startup in this space. And Rick, we really appreciate your insights and knowledge, and it was excellent to have you today. Thank you for your time. Thank you for the sharing of your experience and knowledge in this space. Thank you all for joining today. We will be back soon. Keep track on our meetups on all 3 chapters in Charlotte, Birmingham, and in Jacksonville, and tell others to join. And we'll see you hopefully soon. In a month or so, we'll be posting another virtual meetup until we're able to meet face to face. We hope you're safe and well in this situation, and we'll talk to you soon. Thank you so much, Rick. Thank you, everybody. Take care. We'll talk to you then.
All right, thank you.